Yeah. In this paper by Fergus et al., they have made use of the fact that a recent study has proved that the color gradients of all natural images follow a, a particular distribution, probability distribution, which can be approximated to the sum of Gaussian distributions with mean zero. So using this fact and the Bayes rule for a posteriori probability, the kernel which maximizes this probability is found by an iterative method. The map estimation by iteration is an inference algorithm that's proposed by James Miskin and David McKay. And thanks to Miskin, McKay, and Fergus et al. For sharing their code online. I will make use of them in my project. In this iterative algorithm, in every iteration, the kernel is updated so that this probability is maximized, and for after every updation of the kernel, the original image, the gradient of the original image is calculated with this formula because this is a known, and again we go to the next iteration with this as the priori. So finally we get a point spread function which can be applied to the degraded image. The P is a patch from the whole image which we use for training the kernel. So the third method is the non-uniform blur method. The last two approaches, we assumed that the motion between the camera and the object of interest was linear. This approach assumes that the main contributor to the blur in the image is the rotation of the camera rather than the linear motion, and because of this assumption, the blur in the image is not uniform throughout. The main idea is taken from this paper mentioned here. So the degradation equation, what we used before, is replaced by this motion density function. Aj is the time spent in each position, rotational position of the camera, and Hj is the degradation function at that position. So the overall degradation function is a summation of this, and this gives us a 3D kernel which is applied to the PSF. Using this, we again this approach also uses the map estimation and also uses the inference algorithm of Miskin and McKay. So these are the three approaches that have been tried. We'll see examples later. So once we get the point spread function, we need to do the inverse filtering of the blurred image so that we get the original image. We already talked about blind deconvolution. So this deconvolution cannot be a straightforward process because you can see from this equation that if we apply it directly to the captured image, we get a huge factor because of the noise, and in practice we'll see that the noise factor is so much that the image is almost lost in it. So we can go for either Wiener deconvolution or Richardson-Lucy deconvolution. The Wiener deconvolution is also called the MMSE filter, which is the minimum mean square error. By minimizing the mean square error function, Wiener has come up with a formula for deconvolution where we use the signal to noise power ratio. This is not usually known, but we can approximate it to some value and still get reasonable results by this deconvolution. The second way is the Richardson-Lucy deconvolution. This is a more iterative method. Richardson-Lucy method is an iterative ML optimizer. ML is maximum likelihood. Likelihood is the probability of the conditional probability of the blurred image given the original image, and the algorithm is iteratively updates the kernel also, so that kernel and the estimation of the original image, so that this probability of likelihood is maximized. This works better in many cases than the Wiener deconvolution. We'll see both of them in the next few examples. I've used VNet deconvolution only with the blur parameters. The other two approaches of uh, finding the blur kernel is both using the Richardson-Lucy algorithm, and for non-uniform blur they have a very good demo of the project, and I've used the demo to get the results for my images. So let's look at the examples. Now this is the captured image of boat, and you can see that it is badly shaken. And the restored, this is the first restored image. This is using Wiener deconvolution with the PSF from the blur parameters. You can see that there's a very slight improvement. The image in the red robe is slightly clear, and we can see in the next slide that I've used the same PSF with the Richardson-Lucy deconvolution, and this gives a better result. The lights are a little more, and the lines are a little more clear in this. Even the railings are distinguishable. Next is the map estimation process of the uniform blur. This has added some noise, but still we can see that the details have been enhanced, like this blur has been reduced here, and the lights inside here are also clearer. And the ringing effect is because of the high frequency components, and we can see here that the non-uniform blur has given the best result of all. Like the top of the boat and these lights, they are all very clear than all the other restorations. But still we can see that there's a limit to which we can recover the image. Only up to 30 pixels, blur lengths up to 30 pixels can be recovered from whatever work has been done till now. So there's the other image. Here the blur is very less compared to the first image, the blur length, and so we can see that the algorithms work better with this. They have given a better result. And this is with the Richardson-Lucy algorithm. It has added some noise. The blur in this is not uniform, so though it is very less. So you'll see that the non-uniform kernel has given the best result. The lines in the bench have become very clear, and even the overall image, the face of McDonald and the lace here. So these are the two examples, and here's our conclusion. Yeah, as we know already, accurate restoration of shaken image is yet to be achieved. There's a lot more work to be done in this direction. Even the best algorithm works only for a limited blur. For example, the boat image, actually the horizontal blur is the maximum, but our algorithms have a limit, so they have considered only the vertical blur, and that is what is actually restored. The horizontal blur is not restored. And of course, non-uniform blur estimation gives the best results. So that is the way to go forward in further research. Thank you.